This video tutorial shows you how you can find a suitable gearhead based on the speed and torque requirements of your application. Starting point for gearhead selection is the motion of the load. The necessary operation cycle, speed profiles and friction result in speed and torque requirements the drive has to fulfill. In our standard diagram with motor speed as a function of torque, this can be represented as points of operation. For example, a constant operation at a given torque and speed, or maintaining a position against some external force at zero speed, or speeding up a mass inertia. Usually that's where the highest torque occurs. The use of a gearhead is advisable if the speed is low, typically well below 1000 RPM, and the torque is relatively high. Regarding torque, we condense all the operation points in a few key values: the average RMS load torque and the extreme operation point, usually at the end of the acceleration where the maximum load speed and maximum load torque occur. Let's take specific values as an example. We assume that we need 0.9 Nm continuous torque and 1.8 Nm maximum torque for a quick acceleration to 45 RPM. The selection guide in a catalog offers a good overview of the rated torque of maxon gearheads. The red bars indicate the torque capabilities with respect to the scale at the bottom. The smaller gearheads at the top of the list are too weak. The continuous torque rating is too small. In the lower part, one finds the larger and stronger gears with sufficient continuous torque, starting from diameter 22. We will focus here, however, on the newer gearhead families, the online configurable GPX that can be found in the lower part of the selection guide. Again, gearheads large enough to fulfill our torque requirements start at 22 mm diameter. Let's investigate the datasheet of the GPX22 in more detail. First thing to note that there are different versions: standard, ceramic, low noise and more. However, here we will consider the standard and ceramic versions only. Each gearhead comes with up to 4 stages, each with different possible reduction ratios. In the diagrams we observe that the torque capabilities increase with increasing number of stages, while the output speed and transmitted power decrease. Our application requires 0.9 Nm continuous and 1.8 Nm peak torque at a speed of 45 RPM. The peak load is outside the operating range of the standard version A. The stronger ceramic versions with 3 stages, however, should be a possible solution. So, let us look more closely at the specification of the ceramic version. The torque requirements can be met by a 3- or 4-stage gearhead. The transmitted power on the 4-stage gearhead, however, is too small. The lower efficiency compared to 3 stages gives more heating and therefore the transmitted power rating is reduced. Hence, we are left with 3 stages. Essentially, we selected gearhead type and number of stages according to the torque and power requirements of our application. But now, which is the best reduction ratio to choose? As a general rule, one can state that the highest possible reduction gives the lowest motor torque. The lower the motor torque, the more chances we have to find a suitable motor later on. The highest possible reduction is limited by the input speed of the gearhead. In our case, it is 12,000 RPM. It means that the continuous motor speed should not be higher than 12,000 RPM for this gearhead. Hence, for a load speed of 45 RPM, the reduction ratio of the gearhead should not exceed 12,000 divided by 45 or 267 to 1. The next smaller gearhead reduction available is 231 to 1, with an efficiency of 74%. And that's the gearhead we're looking for. In addition to these considerations about torque, power and speed, there are other criteria for the selection of gearheads. The first one being the mechanical interface. How is the gearhead going to be fixed? And how about the shaft diameter and length? Is there a flat or even a keyway needed for connecting the load? How large are radial and axial loads on the shaft? Check also the maxon modular system for suitable motor types in combination with this particular gearhead. Is it possible to find matching motors with sufficiently high torque? In our case, the RMS motor torque amounts to about 5.3 millinewton-meter. Particular conditions require special gearhead types, sterilizable versions, gears with specially high torque or high input speed, heavy-duty versions for high pressure, vibration and temperature, or other special gearheads. That's it. A short introduction to gearhead selection. In summary, first select the gearhead size and type according to the torque requirements of your application. The matching reduction ratio is found by looking at the load speed and the maximum gearhead input speed. Good luck!